this problem here? Okay, I'm going to borrow this for a second. So what we're going to look at first is one of the homework questions. Number 5 from 5.6. Yes. Well, not yesterday, the day before, as we started these notes yesterday. So our composite functions, which we covered on Tuesday. So we're going to look at one of the problems from last night. And this one here is asking for f of g of x. So for the first problem, number 5, it's just wanting us to find f of g of x. And when we do this here, we're going to start off from the inside out. So we're going to take what g of x is and plug it in for it, which is going to be our 3x minus 5. So we can say that we replace g of x with its function, 3x minus 5, or we put x into g of x, which really doesn't change anything. Now for the next part, f of x is negative 4x plus 3. I don't have f of x, I have f of 3x minus 5. So everywhere there's an x in the function f of x, I'm going to replace it with 3x minus 5. So what that would give us is negative 4, parentheses, 3x minus 5 plus 3. So anywhere there's an x, we replace it with what's inside those parentheses, which for here would be 3x minus 5. And at this point here, we just need to simplify. So we would multiply through or distribute the negative 4 through. And negative 4 times 3x would be negative 12x. Negative 4 times negative 5 is going to be plus 20 plus 3, which would give us negative 12x plus 23. This is our f of g of x. And that's all we would need to do for that one there. And I think number 6 is g of f of x, so we would do the same thing, but instead of using g of x first, we would use f of x. And I think one of the next two is g of x or f of x, so we're just using the same function twice. Does that make sense? Okay. Any other questions on any of the other assignments? All right, guys. We're going to finish up the lesson today. We're going to finish up finding a few inverses and then determining if two functions are inverses of each other. Now this first one here, consider the function f of x equals 2 times the square root of x minus 3. Determine whether it's an inverse, then find its inverse. Well, this function is invertible. Figure that out. Because if we look at the graph, we get this here. This kind of arcing shape. And we can draw a horizontal line, and it's only going to cross this graph once. So it does have an inverse. It is invertible. 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 Now, the way we find the inverse is following 4 main steps. I'm going to rewrite the steps out, but we did have these steps yesterday. Now, the first main step is that we're going to replace or rewrite f of x with y. Our second step is to switch x and y, yes. Third step is to solve for y. And the last step is to replace y. F inverse of x. So these are the 4 main steps that we have. Now, our first step is to replace f of x with y. So we could say y is equal to 2 times the square root of x minus 3. Well, the second step is to switch x and y. So we say x is equal to 2 square root of y minus 3. And again, I said this yesterday, if you feel comfortable with switching f of x and y and then flipping them all in one step, you can do that. We could go from this function straight to x is equal to 2 times the square root of y minus 3. That's perfectly fine. There's nothing wrong with that. But if that's a little bit confusing, go on and take it one step at a time. Now it gives us to our third step. We need to solve this for y. What's the first step we can do? The first thing we need to do. We're going to divide both sides by 2. We can't do anything with the 3 yet because it's stuck inside that radical. So we need to get everything that's outside of the radical to go away first. So when we divide by 2, 2 divided by 2 will simplify to 1, leaving us with x over 2 is equal to the square root of y minus 3. Now what are we going to need to do next? We need to square both sides because we need to get rid of that radical. Yep. Or partially erase that. Now here the square root and square will cancel, telling us that we have y minus 3. Now we don't want to leave the other side as x divided by 2 squared. We can go on and apply that square. So if we square the numerator, if we square x, x squared would give us, well, just x squared. And if we square the denominator, if we have 2 squared, we get 4. Now what's the last thing we need to do to get y by itself? Add 3. Which will tell us that y is equal to x squared over 4 plus 3. So our f inverse of x is equal to x squared over 4 plus 3. And we get this here. Actually, let's go with that. Okay. So now I included this in second hour, talking about the fact that we do have to restrict the domain for the values of x that are greater than or equal to 0. Bless you. Now, before I start talking about the x greater than 0, because again, on the homework, I'm not going to specify or want that. It is technically correct, it's mathematically correct that we need this, but I'm not going to count off if you don't include it. And I'm going to explain why we need this here in a minute. Is there any questions on how we found the inverse? We feel good about finding the inverse, yes? This that I just wrote in purple seems way out of left field, yes? Well, if we talk about functions, kind of as I did the other day, the domain and the range. And our function f of x that we started with takes points from the domain and maps them to the range. It takes our domain to the range, our x values, and takes them and connects them with a specific y. Now, if we look at the graph of this here, well, the values of x, the only ones that show on this graph are any of them greater than 3. And all the y values are contained in that first quadrant. So we only really have y values that are greater than 0, yes? So what that's telling us is that we're taking x values that are greater than or equal to 3 and mapping them to y values that are greater than or equal to 0. Those are our domain and range. The inverse takes the values from the range back to the domain. So for the inverse function, what values is it stuck for taking with? Values that are greater than 0. That's why we had to add that in, that x is greater than or equal to 0. Those values have to be greater than or equal to 0. Now, that kind of makes sense in that point, but let me go on and graph our function. Alpha y equals, enter, because we had x squared over 4 plus 3. And I'll graph it. Well, here we do have positive and negative values for x, because it's in the positive and negative side of the graph, yes? And these are always going to be reflected across that y-axis. Well, we only include the ones greater than 0. We only include that half. The other half of that graph is actually the part, that would be coming down this way here. This part of the graph matches up with this part of the graph. We didn't have the lower half for our original function, so we can't have the left side of that red graph because they don't match up. That's also why we have to include that restriction. Now, that away. For what I'm concerned with, I'm not focused on that. College algebra, depending on the college algebra teacher that you have, might include that, might want that, but I'm not going to focus on that there. Any other questions on how we found the inverse function? Not so much how we found that. We good with this here? Oh, wrong way. All right, we're going to find one more of these here with the square roots. Okay. Is it invertible? Well, yes. We can take the inverse of it. Now, our first main step for finding the inverse is y equals 3 times the square root of x plus 4. Now, our next step is to switch x and y. So we'll say x is equal to 3 times the square root of y plus 4. Now that we have those flipped, we can go on and solve for y. What's our first step? Divide by 3. Yeah, with finding these inverse, it's good to get the radical by itself. We could do that at this point, and it wouldn't be too bad, especially since the side with the radical only has one individual term. And it would work out not too bad, but it's a little bit better to get that radical by itself first. So tell us x divided by 3 is equal to the square root of y plus 4. Now we can square both sides. And luckily, when we square a square root, they simplify out. X divided by 3 squared would be over 9. And last but not least, subtract 4 from both sides, which will tell us that x squared over 9 minus 4, yes. Minus 4. Which tells us that f inverse of x is x squared over 9 minus 4. Any questions on any of this here? I'm going to skip that f of x equals negative x squared, and we're going to look at this one here. This one here is the last one we're going to find the inverse of, actually find its inverse. In the last set, we're going to work it out so that we determine if the two functions given to us are indeed inverses. So any questions on that here before we look at this next one? We're good? All right. Huh? I don't know. I just decided to wear this shirt today. Thank you. It's been a while since I've worn this one. Don't know why. All right. So what can we do first? So the first step for this here is to replace f of x with y, and then we do what? We switch x and y. So x is equal to negative y cubed plus 4. What do we do next? So we do have 3 different things going on. We have the negative in front of y cubed, we have the cube, and we have plus 4. We can subtract 4. Because the 4 minus 4 would be 0, telling us that we have x minus 4 equals negative y cubed. Now what can we do next? We can divide by negative 1, or we can multiply by negative 1. Either one works. Because what we're wanting to do is get the y cubed going from negative to positives. Equals negative x plus 4. Another way I think about it is, well, I need the y to go from negative to positive, so I switch it from negative to positive. But then I change everything else from negative to positive or positive to negative. We're just flipping the signs. All right, what's the last thing we need to do to get y by itself? Well, we have the cubed, yes? How do we get rid of a third power? We cubed root it. So we'll cubed root both sides. The cubed root of y cubed will be y equals the cubed root of negative x plus 4. So our f inverse of x equals the cubed root of negative x plus 4. And that's all we need to do for this here. Any other questions on these here? And that's it. We don't have to put any restrictions for this cubic. Most odd powers, most are invertible, and we don't have to do anything to them, but there are some that aren't. Any questions on any of this here? All right. The last thing we're going to look at is verifying functions are inverses. So on this here, they're going to give us 2 functions, and we want to determine whether or not they are inverses. One way we can do this is just pick one of the 2, so f of x, and do what we just did to find the inverse. And if that inverse matches up with g of x, then they are indeed inverses. The other way is using our composite functions. And for us here, if f of g of x gives us the exact same value as g of f of x, then these 2 functions are inverses. And more specifically, we're not just looking for them to be the same, we actually want both of these to be x. We want both of these to simplify down to x. Now the reason this works this way is, well, get our domain and range circles back out, x and y. Because our normal function f of x would take a x value in the domain and map it to a y value in the range. That's just how a function works. I plug a value in, I get a certain value out. Now the inverse, as we saw, takes that value that we got out of the range the y value, and maps it and takes it back to the x value. When we looked at this yesterday, they gave us the value negative 11. And when we solved for it, we got the value of negative 5. Well, we plugged it back in the original function, and it took us from negative 5 back to negative 11. We went from one to the other. Now, that's if this is an inverse. But what we're doing, I'll call this g of x. So f of g of x. And we'll use these numbers here. So f of g of negative 11. Well, as we saw the other day, negative 11 took me to negative 5. So we're saying f of negative 5. Well, what is f of negative 5? It is negative 11. I ended up back where I started, yes? Well, if I said that we started at not a negative 11, but x, I'll erase, this here would end up being equal to x. They undo each other. And if we have the same thing for g of f of x, and these are inverses, this should come back to being x. It should go back to where we start. So that kind of makes sense of why these work. Kind of, sort of, or just pure magic. But for inverses, these composites end up being the same thing if f of x and g of x are inverses. So we talked about composite functions on Tuesday, where I said there's only a few select that actually are the same. And that's only if the two are inverses. If the two functions are inverses, then f of g of x and g of f of x are the same. That's the only way that they work out to be the same. Should be. So let's look at this one here. Now g of x in our case is x plus 1 over 3. So the first thing we'll do is replace g of x with x plus 1 over 3. And now at this point here, we're going to take that f plus 1 over 3 and replace every x and f of x with it. Every x and f of x. So this one here is going to be replaced with our x plus 1 over 3. So we'll have 3 times x plus 1 over 3 minus 1. Well, what's going to happen with that 3 that we're multiplying the parentheses by and the 3 in the bottom of that fraction? They're going to cancel out. Now, normally we would just cross them out, but I'm going to go on and show it because here, when we multiply a whole number by a fraction, we multiply it by the numerator, the top. Now, a lot of times we would have gone on and multiplied the x plus 1 by 3, but here we're wanting to simplify down. Because here, 3 divided by 3 simplifies to 1. So that simplifies to 1, leaving us with x plus 1 minus 1. 1 minus 1 is 0, leaving us with just x. So that tells us that f of g of x is x. And that's exactly what we expected to happen. Any questions on this here? So f of g of x is equal to an x. Now for this problem here, we are expecting g of f of x to also equal x, mainly because the directions told us. Because it told us to what? Verify. Verify is the same thing as show. So these are going to be inverses. Now if we do this here, apparently I'm going to scroll, we'll have g of f of x is our 3x minus 1. And again, just like in the previous problem, we're going to replace every x in the function g of x with our 3x minus 1. So in the numerator here, we'll have parentheses 3x minus 1 plus 1 divided by 3. Well, I can drop those parentheses because it's just, there's nothing in front of it. There's no sign in front of it. So it's going to stay the same. The signs are going to stay the same. 3x minus 1 plus 1 over 3. Well, negative 1 plus 1 is 0. So we have 3x over 3, which is, surprise, surprise, x. So what that tells us is that f of g of x is equal to g of f of x, which is equal to x. So yes, they are inverses. We've been able to show it. Questions on any of this here? Now, most of the functions that we will look at in this class here, doing this, these composite functions, isn't that bad. Some of the ones, if you take the pre-calculus class when we get to this point, it's sometimes easier to find out, take f of x or g of x and see what its inverse is by doing our 4 main steps than it is to plug it in, because there's a lot of different operations. Because we could be looking at a function and then its inverse, possible inverse, involves radicals, so square roots or cubed roots. X has got a power greater than 1, so squared and fractions. So sometimes there's a lot going on. But for the ones we look at here, they're not that bad. Any other questions on this here? We're going to look at 2 more. Not that one. We're going to look at this one here. This one here is actually not that bad. Now, do we know for sure that these two are going to be inverses? Well, no, they changed their wording from verify to determine. Determine means it could be or it couldn't. We just need to figure out. So the first one I normally do when I'm trying to figure out if they're inverses is f of g of x. It doesn't matter which one we do first. We could have done g of f of x first. We just need to pick one. And I know that this is going to be an inverse or possibly an inverse is if f of g of x equals what? X. If I get anything besides x, will they be inverses? No. If I get a constant number, if I just get a number, they're not inverses. If I get 27x squared, they're not inverses. I need just x. So here, the first thing we'll do is replace g of x with its function, which is our x minus 5. Now our f of x is x plus 5. But since I don't have f of x anymore, I have f of x minus 5. We're replacing the x with x minus 5. So what we'll have is x minus 5 in parentheses plus 5. Well, that there is x minus 5 plus 5, which is apparently nothing. X. So is that the value that we wanted for these to be inverses? Yes. Okay. So we'll need to go on and check the other one just to make sure. That for some reason they didn't find one that only worked in one case, not both. So g of f of x. Now our f of x this time is x plus 5. So our f of x was x plus 5, so we replaced it. Now we'll plug that into g of x, which will tell us that we have x plus 5 minus 5. So again, just like the one before, we can drop the parentheses, which give us x plus 5 minus 5, which gives us x. So are these inverses? Yes. And we know it because f of g of x is equal to g of f of x, which equal x. That's why we know that they are inverses. Any questions on any of this here? Last problem of the day, if there's no questions. We're going to look at this one here, and this is the last one we're going to look at. F of g of x. And we're going to look at the composite functions for this here. Now, g of x in our case is the cubed root of 2x. So we replace g of x with what it is, the cubed root of 2x. And now we're going to plug the cubed root of 2x in every place in the function f of x where x appears. So that'll tell us that we have 8 parentheses cubed root of 2x cubed. Now luckily for us, the cubed root and third power will cancel each other out. There's only one term in there, and it's just that cubed root, so it simplifies out completely, telling us that we have 8 times 2x. And 8 times 2x is that what we wanted? No. So are these inverses? No. I don't even need to find g of f of x. Because again, if they're inverses, f of g of x and g of f of x have to be the same thing. More specifically, they both have to be x. Because if they are not both x, they're actually not inverses. So we can actually stop here. For what we actually need, g of x would actually have to be the cubed root of x over 2. If we actually wanted these to be inverses, this is what we would need. Did this actually ask us to find what the inverse was? No, it just asked us to determine if they were or not. But if f of x was that, this is what our g of x would be. And the other way around, f of x, if we wanted this g of x, we would actually need it to be, let's see here, so x cubed over 2, if we wanted it to connect with that function there. But again, that's just working backwards from what we have. Because if we're looking at this function here, if I plugged an x value in, we would multiply it by 2 and then cubed root it. Going backwards, cubed first and then divide by 2. But again, knowing that's not essential. Now this is your last assignment for chapter 5. It's on page 289. Problems 13, 15, 17, 23, 24, 26, 36, 38, 41, and 49 through 51. Don't graph. Like I said at the beginning of the year, unless I specifically tell y'all to graph something, don't graph. I'm not going to make y'all graph any of these here.